So today's lesson actually goes with last chapter. In last chapter we were solving quadratics, but last chapter we were solving them by factoring them. Do y'all remember this? And then we would set each of the factors equal to 0 and solve. But I taught y'all a trick, and I said, hey, you can use your calculator to solve quadratics. Do y'all remember that? Yes? Well, today it doesn't think you've ever learned this because you were supposed to be factoring them all in the last chapter. I just taught y'all the trick, okay? So this should be a super easy day for you. The biggest thing you need to know is that if you want to solve a quadratic by graphing, the first thing you have to do is set it equal to 0. So it has to be in standard form, ax squared plus bx plus c, but you also set it equal to 0. Now, if you want to use your calculator, do y'all remember what to do? You put this side in, y1, and you have to put 0 in y2 so that it can find those intersections for you. So if you want to label that, if you want to use your calculator, this side goes in y1 and this would go in y2. Yes, you would have to do second trace 2 times so that you can find both of those intersections. Okay, we're going to actually graph them ourselves and find the intersections, and then we'll also be able to use our calculator as well. So the first example says solve this quadratic. Okay, well the first thing you have to do is put it in. So you've got to set it equal to 0. You've got to get everything to the left. So this 3 would have to move to the left. Yes? Now we're going to pretend we don't have our calculator right now, okay, to solve. Okay, so we got to put it in standard form. So let's do that. I have x squared minus 2x. How would I get the 3 to the left? Minus 3 equals 0. Now, if I want to graph this, I want the axis of symmetry and I want the vertex. I want to know what it is. Do y'all agree? So I would use this formula to find the axis of symmetry and the vertex. So negative b over 2a. So negative b means the opposite of b. Yes? What is b? So what's the opposite of that? Positive 2. So I have 2 over 2 times a. Well, what's 2 times 1? 2. So what is 2 over 2? 1. So my axis of symmetry is x equals 1. And then can I also, it says find the minimum or maximum. Doesn't that mean the vertex? Yes? So I would plug 1 in for the x's. So 1 squared minus 2 times 1 minus 3. So right here I just set that up for you. So 1 squared minus 2 times 1 minus 3. So let's go put that in our calculator. 1 squared minus 2 times 1 minus 3. What do we get? Negative 4. So the vertex is at 1, negative 4. Or we could also call it the minimum. Does it open up or down? Up. Now it wants us to find the x-intercepts, the zeros, the roots, or the solutions. So we're going to graph it, and that's how we're going to find it. Now, did y'all see a new word? Y'all know they're called x-intercepts, yes? I taught you the other day they're called? Did I teach you that they're also called roots? So that's another word for an x-intercept, and then they're also called a solution. Okay, so we are going to find the solutions. So here we go. Let's go graph this. We know the vertex is at 1, negative 4, so I'm going to go ahead and put a dot at 1, negative 4. That's the only point we have so far. So now I'm going to go use my calculator and at least get my table filled in. So x squared minus 2x minus 3. And I'm going to go to my table and fill this in. I know that my vertex is at 1, negative 4. So that's going to go in the middle. And then we're just going to go graph it. And these 2 points right here are called the solutions, also known as x-intercepts, also known as zeros, and also known as roots. So all of these lessons kind of mesh into each other, just asked different ways and presented in different ways, okay? So today should be super easy. Let's do one more example, and then I think y'all are good. I might talk to y'all about one more thing, though. So let's go do this one. All right, what do you have to do with this before you can do anything? Move the 5 to the left and set it equal to 0. So I have x squared plus 4x minus 5 equals 0. Now, yesterday I did teach you that you can go in your calculator and try to find the vertex by looking where it mirrors itself. I think you figured out on the homework, though, that you can't always see it in the calculator because sometimes it's a decimal, right? And your table doesn't give you x values that are decimals. They only give you whole or integers, yes? So if you ever need to, if you can't see it, use the axis of symmetry formula and find the vertex yourself. Does that make sense? Yes or no? Okay, so let's go see if we can see it. So let's go to y equals. We're going to put in x squared plus 4x minus 5. I'm going to go to my table and see if I can see where it starts to mirror itself. And I think I see it. Did y'all find it? So right at -2, -9, it mirrors itself to the left and to the right. So -2, -9 is the vertex. Now, if I couldn't find that using this table, I would use my axis of symmetry formula and then solve for the y so that I could put that as my vertex. All right, so now I'm going to write that -3 goes with -8, and -4 goes with -5. -1 goes with -8, and 0 goes with -5. Bless you. I'm going to go graph it. Now, what I don't want to do right now is draw a line until I have figured out my x-intercepts, because the whole point of this is to solve it by looking at the x-intercepts. So I want to find where it touches 0. And I see it right here on my calculator screen. The x-intercepts is where the value of y is 0. So it's going to touch at -5, 0, and 1, 0. So it's going to touch here and here. Do y'all understand where to look for it? On here. Now, is it always going to give it to you on this screen? No, so you might have to use second trace. If you use second trace, you have to go put your y2 is 0. You have to, or second trace won't work because there is no intersection. So then I go to second trace, option 5. It's going to graph it for me. See how that's where that's y equals 0 is that red line right there. I go to the first one that I want to do. I hit enter, 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 and it tells me that the intersection is at 1, 0. And that's this one. So if it's a decimal x value, it's not going to show up on the table. You've got to use second trace if you can't see it. All right? Or could I just factor this? Could I have factored this thing right here and then set them both equal to 0 to solve? Yes. That was the last chapter. All right, so what are my x-intercepts? -5 and, anybody? And 1. So -5, 0, and 1, 0. Those are my intercepts. All right, let's go over some vocabulary. What is the vertex of this point? -2, -9. What, does it have a minimum or a maximum? A minimum, which is also the vertex. Where's the axis of symmetry? Give me it as an equation. X equals -2. What is the domain? Why is the domain all real numbers? Because the arrows are going to keep getting wider and wider and wider. So all real numbers. What is the range? Very good. Y is greater than or equal to -9. What are the solutions? -5 and 1. What are the x-intercepts? -5 and 1. What are the zeros? -5 and 1. What are the roots? -5 and 1. Those are all the different words they can use to ask the same question. Yes? Okay, the last thing, this is not an example, but if you would flip to the very back. And I just want to talk to y'all. We will go into this in further detail later. But quadratics can have 2 solutions. These are most of them, yes? And that's if they touch the x-axis 2 times. Are y'all with me? They can have 1 solution if they only touch it 1 time. And they can also have no solution. If they're above the x-axis and it's never going to touch the x-axis, then there are no solutions to that quadratic. Do y'all understand the 3 types of answers? Why? Because there are no x-intercepts. Do y'all have questions on that, or y'all okay? So if you graph something and it's above the x-axis and it asks for the solution, your answer is? There is no solution. Or, I'm going to look. All right, if you would put your name on your assignment. At the top, it wants you to determine whether the given value is a solution of the equation. So your answer will be yes or no. You have 2 different ways you can do this. They are already set equal to 0. You can use your calculator and put the left in y1, yes. Put the right in y2 and see if it's touching the x-axis at 3. If it's not touching, the answer is no. You could also plug 3 in for x and see if it gives you 0. If it doesn't give you 0, the answer is no. So there's 2 different ways to do that. All right, 7 through 12 says, use the graph to find the solutions. Guys, the answers are already there for you. All you're looking for is where it touches the x-axis. So look at number 7. Where is it touching the x-axis at? Then that's your solution. How many solutions did this have? Only 1. Why? Because it only touched the x-axis 1 time. So yes, there are some with no solution. Do you see it? Okay. So if it doesn't touch the x-axis, the answer is no solution. You can either write the words or you can draw the circle with the line through it. Now, if you put a 0, you're telling me it touches at 0, so don't put a 0. Okay? All right. On 13 through 18, it wants you to solve the equation by graphing. Well, the first thing you have to do is set it equal to. So write that down. Set equal to 0. And then you can simply use your calculator, put it in y equals, and graph it. I think all of these are integers, so you can see the answers, but absolutely use your calculator if you need to. Okay, it wants the solutions. If you write them as coordinates, that's fine. Or if you say like, hey, it only touches at -4, that's fine too. All right, flip to the back. On 19 through 24, it wants you to find the zeros by graphing. Isn't that the same thing you're just doing on the front? Yes, okay. If it doesn't touch the x-axis, the answer is no solution. And then I would like y'all to try to do number 25, but you don't have to do 26. But you need the vertical formula. So let me write it down for y'all. So on 25, it's h equals -16 t squared plus VT. Y'all remember learning this, right? Plus S. And then we'll talk about what each part means. Remember that H is the height. The V is feet per second. And the S is the starting point. So they gave you some numbers. You're going to have to fill them in, and then you're going to graph it. And then let me go over it with y'all. So I'm going to wait for you to finish writing. Okay, so right here it says a movie stunt double jumps from the top of a building 50 feet above the ground. So where's the 50 going to go? That's your starting point. So this is going to be your S. Onto a pad on the ground below. The stunt double jumps with an initial vertical velocity of 10 feet per second. Where's that going to go? That's your V. So you're going to fill those numbers in. The T is your X. That's your variable. You're going to graph it. Use your calculator. So A says write and graph a function. So you need to write this equation with the V and the S filled in. Yes? And I want you to graph it. Now you're only graphing in quadrant 1 because this is a person jumping and they can't jump into negative air. Yes? Now part B says how long does it take for the stunt double to reach where's the ground at? 0. So isn't that the solution? So wherever, if it touches right here, then it took her 0.5 seconds. If it touches over here, then it took her 2 seconds. So she jumps. She starts at 50. She jumps. It's going to be a curve, and wherever she hits, that's how many seconds it took her to get to the ground. Make sense? All right, get started.